Hello, in this video, we're going to learn about the effect of volume on a system at equilibrium using Le Chatelier's principle again. Firstly, I define Le Chatelier principle. So we learned in the previous video, Le Chatelier principle mentioned that if a system at equilibrium is subject to a change, the system behaves in such a way to minimize the effect of the change. Today, our example is change to the volume. Let's see what happens to our system. You know, when we talk about volume or pressure, usually we talk about gases. So right now I have this system for production of ammonia. Definitely the system is a closed system because if it's not closed, we can't reach equilibrium. And the change is we halve the volume of container. Let's see what happens. You know, if we halve the volume of container, we still have the same number of molecules, but in a smaller volume, half the volume. So it means actually the partial pressure or the concentration doubled. So by halving the volume, actually, I can say we double the concentration of all gases involved. So we need in our diagram to increase the concentration of all gases, and it's a sharp change. So as you can see, N2, the concentration is 0.1 mole per liter. So it has a sharp change to 0.2. Okay. And H2 has a sharp change from 0.3. If we double it, it's 0.6. If you draw it, it's better to use a ruler. So you draw a sharp and straight line. And NH3 is 0.7. So it needs to increase to 1.4. However, my line is not straight, but it should be. After that, we can see we have a change to our equilibrium. So based on Le Chatelier principle, we need to minimize this change. If I increase the concentration of all gases, or we can say the partial pressure of all gases, you see all partial pressure double. It means the total pressure of system increase. So the change is actually increasing the total pressure of the system. So according to Le Chatelier principle, the system should go to the direction to minimize this change. When I look at the equation, I see here I have 2 moles of gases, and here I have 4 moles of gases. You know, if we have more number of molecules of gases, it means pressure is higher. So the only thing that we need to count when we talk about pressure is molecules of gases. About solids and liquid, we don't need to count them because they don't affect the pressure of the system here. So I have 2 moles of gases and 4 moles of gases here. So we see the concentration, or as a result, the pressure increase. So we want to minimize this change. The system should go to the direction to decrease the pressure. If you go to right side, you see the number of moles of gases decreases. So it means the pressure decreases. So actually, based on Le Chatelier principle, we can say the equation needs to shift to the right. Let's see what happens. So it means the concentration of NH3 needs to be increased. So let's say it increases by here, and then it stays the same. It means at this point we have equilibrium. So as a result, if concentration of NH3 increases, it means we use our H2 and N2. And because the ratio of N2 and H2 is 1 to 3, it means for any 3 moles of H2, we just use 1 mole of N2. or we can say for any 2 moles of NH3 that we make, we just use 1 mole of N2. So for N2, if this one goes from 1.4 to 1.6, it means 0.2. So this one just goes from 0.2 to 0.1. We have a drop close to 0.1. A drop because we are using that. Okay. And then constant. At the same time that this one is constant, this one also should be constant. Okay. And H2 also use, but if we use 1 mole of N2, actually we use 3 moles of this one. So it drops to something similar to here. So you see the number of moles of NH3 increase, H2 decrease, N2 decrease, and again the system reached to the equilibrium. But none of them reached to the same concentration before our change. Just we minimize the effect of the change. I hope you found this video helpful. If you like to learn about the effect of change in temperature, please watch the suggested video. Thank you.